Today we'll learn about the function annotations, which fit more with the function section. But in addition, a relevant topic is variable annotations. Let's go in details. First, let's specify what is BAP. We refer to that in an informal way, but maybe some extra little information is good. BAP stands for the Python Enhancement Proposal. And you can think of that like the design document providing information to the Python community or describing a new feature for Python and so on. If you noticed in your PyCharm editor, if you have extra more than 2 lines between couple of functions, like consecutive, you will notice that the PyCharm is giving you something saying pip8 too many blank lines. What is PyCharm doing mainly is referring to the pip guidelines for the style code for a Python, and is giving you some warning based on that. There is no syntax error here, but just the style guide. So pip in general is defining a lot of things for the community so that we create like a standard or notify about new features. 2 of the recent features in Python is the function annotations and the type hints. This is the pip 3107. This is the number of the feature. When you would like to know more about the history of the feature, whatever provided, you go to the feature and learn about it, and so on. Anything that you find in Python, you can go back to the history of a version after another to see what happened exactly. So these are the 2 links of that. This is just more of background for you. Now let's go in details. I would like you to take a minute to read this function and guess what is a bit new in it compared to what we learned. If you read here, it seems we have 3 extra things. We have here, after the variable, we have colon float, and then we have after the y colon float, and before the colon of the function, we have here an arrow float. This is, we are communicating to someone who is using our function that we expect x to be a float and y to be float and the return of the function to be float. If you are coming from languages like C++ or Java, you will notice that they are statically typed languages. By default, you write the type of the variable before using it. But Python is more of dynamic. X and y can be anything and can change over time, and all of that what we learned already. So the interesting thing here, we are providing this function annotation about what are the expected arguments, what are the expected return. But observe, the Python interpreter ignore them. So this isn't like C++ and Java. We still that dynamic and flexible language in Python. We are just communicating that for the caller. In addition, and we'll learn that by the end of the session, that there are some libraries that do static type checking for your code before you run it. So instead of just run your code in production, you run one of these libraries first on your code to check if what you are using matches the processing or not. Observe here, this function is adding the 2 inputs, and as we know, if the inputs are integers or floats, it's going to work well, but also if they are strings, it's going to work well. So now here we are calling add with 2 and 7, and we are calling add with 2 and 7 as strings. Here they will be added, and here they will be concatenated. Observe here, the Python interpreter doesn't complain that these are strings and we expect floats. Python interpreter discards them. So be careful about that. We write them to communicate mainly, or maybe for some third type checker community. If you try to print the add and use the annotation here, it is going to give you like a dictionary of what kind of annotations are provided with the function. Now let's go one step more and learn about the recent type hints. A type hint is now giving also a hint about what is the expected variable type of some variable. So again here, take a minute to read the code. We are, instead of writing z equal x plus y, we are writing z colon str equal x plus y. We mean by that z here is expected to be a string, and result is expected to be a list. The annotation here is mainly for the function, not for the variables. And again, observe, I can call the function with with whatever I wanted to. There is no forcing here from the interpreter on something. Let's try to go more complicated. Let's say you are in a division function, and you know when you try to divide x and y, there might be a case that y is 0, so you cannot return the result. So you developed a function dev that check if y equals 0, it returns 1, otherwise it returns x over y. If you try to return float only, it doesn't make sense now, because there is actually two cases here, two different returns. So how to express that? In Python 3.8, you have this typing module that you can import to the union from it. Union here is referring to multiple things. So I can here say union of float and none, which mean we can return a float or none. There is also one shortcut for that. You can write optional of float. Optional also is something that means that this is an optional one, and otherwise we can return a none. So these two syntax are the same. Let's go in much more complex things. First of all, up to Python 3.8, to indicate typing, you can use the define one union list tuple dictionary, but all of them starting with a capital letter. Okay? From Python 3.9, you will not need these capital letter things. You can use the normal ones. But in case, because many of you might be using 3.8 or less. So here are some syntax. This function is returning a list of integers. So you can refer that this is only returning list. Now it can be list of anything. But what if I would like to be more specific that this is list of int? I can say here list of int. In this function, I'm saying I'm returning a list that can be integer or string or none. Okay? So you are expected to return something like that. But you aren't expected to return something that has 1.5, which is float. I can also in a very similar way create variables. Like t1 will have these values here. But I can say it can be list of float or string or bool. Okay? But observe that the bool is like just kind of integer here. And I have here list of list, and the internal list can be list of integers. And have list of list, and each element can be integer or a string. I have a tuple. Now observe with the tuple the following. With the tuple, if you have a tuple of 3 elements, you have to specify for every one of them what is the type. You cannot just write tuple of int. You have to write tuple of int for the first element, int for the second element, str for the third element. If you'd like to indicate that they are all of them int, there is a shortcut. You can write int, comma, then 3 dots. This ellipse here refers to the a tuple of a lot of integers. And similar to the previous time, if you just would like to indicate that it's just a tuple of whatever, then you can just write a tuple. In a similar way, you can also define a dictionary. Dictionary of a string and int means that it maps from a string to integers. So this is how you can change the function annotation or the variables to indicate strongly to the people what are exactly the variable types. Now, overall, remember, the Python interpreter doesn't consider them. They are all ignored. And one advantage of annotations and data type hints, they encourage you to think about your logic. If you are coming from C++ and Java, you know that we start to thinking about really what are the arguments, what are the return, what are the variables. Even some of the guys coming from C++ and Java communities might stick to the type hints all the time because they keep thinking in the same way. And also, as we learned, it can communicate early the arguments, the return for the APIs that we are using. As I said, there is some third-party libraries that can statically check your code. I will show that after that now. There is a debate around using them. Is it Pythonic? Some guys don't like them, and they might end up with doing something like duck typing plus try except a block. Try except a block here is if there is anything wrong with the passed parameters, then I'm going to catch it and try except and just return for it. I would say do not heavily use type hints. Think about them. Are they added value in a specific positions? Use them. This might be very useful, for example, in APIs or anything that might cause confusion. And this is a link for future reading. I would like finally to show you what I mean by the MyPy tool. They are external tools that you can install and use. I know that I didn't teach you so far how to install something that is a third library, not now, but if you have interest to play, you can just pip 3 install my buy. I don't want you to go and install and try. Yeah, like this is very optional for now. Here is a code. Observe in this code we have a division of x and y, and we are returning a float. But observe here, the y here is returning none, and even by charm is detecting something is wrong. Now, from Python interpreter, there is nothing wrong about this code. It can run and then crash. That's okay. But if you try to run the mypy over the code as follows, instead of go to the terminal, and instead of writing python 04.py, you run mypy 04.py after installing it. Now what happened here, in the output it starts to complain and tell you error in line 3, that you have a return none but we expected flow, and error in line 7, that we are passing a string but we are expected flow. So this is what we mean by third library that do static check. By that we mean an early check to your code if it matches the annotation and type hence or not. And in many big companies, some of them might be using something like mypy or their internal tools to verify that the code is working well, good enough, because the matcher of Python can be a bit problematic in production in real life scenarios. That's all.